Welcome back to our second session on C++ Essentials with DirectX.
Okay. Yep. Cantaloupe color, whatever. Cauliflower blue.
Cornflower blue. That's
Cornflower
right,
blue,
that's right.
yes.
So when we left off last week, I had a bug in SquareChase where the colors were not displaying the way that they were supposed to. And I figured out the reason for that was because of the way that I had written some of the game logic. When I was loading the texture, let's see, where do I load the texture? When I was loading the texture, basically I was loading the texture like pre-tinting it black. So I had to find the place where I was loading the texture and make sure that I was loading it with the colors enabled. Where is that? I thought everything that we did was in game. There we go. Yeah, it was in the game logic.
Ah, there we go.
Yeah, it was in the game CPP is where it is. So let's see, where's the load? I think this is it right here. Yeah. Oh, well, no, I guess it wasn't on the load. That's right. The load worked fine. It was somewhere I was setting the alpha value of, I don't remember where I fixed it, to be honest. I went and fixed it last week after I figured out what I did wrong. And I don't even remember where the code is. But anyway, the problem was that I was setting the alpha. Yeah, anyway, I was setting the alpha to 0, 0, 0 for red, green, blue. So it was making the circles or the squares all render as black. So anyway, I figured out wherever I was doing that wrong and fixed it. So now the colors display the way that they're supposed to. And when you click the box, you increments your score and changes the color. And so that works the way that it's supposed to now. And I'm not very good at this. Ooh, that was like 5 or 6 in a row. Yeah, that would be a fun thing to do. We could add a challenge to it to like have it keep track of exactly how many in a row you get. Give you
that's weird. Points. It doesn't show up. Oh no, there it is. Okay, for a second it wasn't showing up.
What?
It just showed you clicking on this, like your code, but not the game.
Oh, it wasn't actually showing this window?
Yeah, but now it is.
Okay. Well, I was thinking that kind of makes sense, maybe because this is Direct 3D, so it's like rendered on the GPU. I mean, like some of those things, like movies, for example, if you try and play them over a stream, it like blacks out the movie because it's all through the hardware.
Ooh, true.
Hopefully that's working. I mean, that's
oh no, it's working now.
Like, yeah, I mean, like streaming DirectX stuff is no problem. Anyway, where was that? I really am like, I'm kind of scratching my head now thinking about where was it that I was loading that texture and setting that color. Or maybe, oh, wait, I remember what it was, right? When it is in the header, it's this right here. No, dang it.
It's somewhere. We'll find it.
I know what the bug was and I fixed it and I don't remember where. No. Oh, you gotta love that. I mean, this is so much my life. Somebody made a comment on Discord the other day that I thought was just absolutely appropriate. My worst enemy is myself from 2 weeks ago.
Why is this so relatable?
All right, so anyway, yeah, right. So anyway, we're going to get started on flood control now. So I went ahead and just started from the base template on this one without putting any of the modifications in there at all so that we can see what we actually need to do there. And so one of these mains here is the main from SquareChase, and then the other main here is the new one from the template. So this one on the right here is the new one from the template. One on the left here is the one from SquareChase. The reason why I know that is because it's got all of this extra stuff in here at the bottom. So let me first double check and make sure that I may not have done the property things that I need to actually get this ready to use the DirectX toolkit. No, I don't think that I have the DirectX toolkit.
Like what you need to do for this game? Yet. Or what you did?
Well, I need to, right. These are project settings I have to set up for this specific project. So you'll see that I got this value in here for the DirectX toolkit include folders. And so I need to make sure that those are in here. So the project properties, you have to edit them, from the template to point to where your DirectX toolkit is at. I think I also need to set the input. Input for the libraries, if I can remember where that is. I think it's under linker. Yeah, input. There we go. DirectX 3D, DirectX GI, UUID. I don't like this value. I have a better one. I'm going to use mine from my other project here. So these two things that I just set here, one of them is, so this adds libraries, like system libraries. This is WinSox 2, the Direct3D 11 library, the DirectX graphics interface library, and the DirectX, I think this is the DirectX debug library, GUID. No, I'm not positive about exactly what it is because GUID stands for globally unique identifier, but I don't think that's what that stands for in this particular scenario. Anyway, this is just basically making it so that your project can access the right libraries on the system. And then the include folders that we did over here was giving the, where is that? Was it in general? Yeah, it was telling this project where to look for the DirectX toolkit files, which are in this project right here. So this is where we've got our model viewer, our primitive batch, our sprite batch, our sprite font classes, the simple math stuff that gives us our vector 2s and rectangles, the texture loaders. It's just a toolkit of a bunch of code that does useful things for 3D rendering in DirectX 11. So we reference that. We got to make sure that it's actually also hard referenced here. This way, when the compiler runs, if there have been any changes in the DirectX toolkit, which I don't really ever change it, but if there had been, it would recompile it. So it just flags it as part of this. The only thing that I did really beforehand was I went ahead and processed these 3 PNGs into the DDSs that need to be there, and I won't bother with that until we do another one of these next time, maybe. So got those added. And yeah, so that should then make it so that we can now put in our references for keyboard and mouse. So first off, we got to include from the DirectX toolkit. The keyboard and mouse includes libraries. Oh my God.
Very important. Can't forget those.
Keyboard and include mouse, right? All right. So keyboard and mouse get added into there. The next thing that we have to do, so this is the message handler is what this is right here. So the way that this works is that the operating system sends your application events about things that happen. So I'm gesturing. If I move my cursor across the screen, that probably generated about 1 million events in the operating system. Those events were for each of those pixel moves and a bunch of other things going on with which window part was active and other kinds of things. All of that stuff gets handled by a process in your application that's a Windows procedure or WinProc. It's the callback from the operating system. So this actually is what drives the game loop. Basically, there's a while loop that sits there and it checks the message pump from the OS to say, hey, did I get any messages from the OS that I need to process? And then if it doesn't, then it just sends a tick, which the tick command in this, so you see this right here on the right hand side, this tick. The tick command is actually like a single entry point where it calls update and then draw in a loop. So we need to add, we need to add the keyboard message processing to, which one is this? This is syskey down. The syskey down probably already exists in here. Yep, there's syskey down. There's some boilerplate code in here that makes it so that if you press Alt-Enter, this will toggle full screen. Although I'm fairly certain that that's actually disabled in this version. It doesn't support full screen. But anyway, we call the static method on the keyboard class process message, and we just pass it the W param and the L param, which I'm not sure what W or L stands for, but we have to make sure that the process message gets this. So the keyboard
Would
class
W be
contains
width and L be length?
well, in this particular case, what they're actually meaning by this is wide and long,
Oh.
not width and length, but wide as in a wide character,
Mm.
and long as in an int.
Okay.
Right. So I think the difference between them is that the W param is maybe 64 bits and the L param is 32, as a guess.
Okay.
But I don't know actually what it is, but yeah. So then the other thing that we have to do is then we actually have to add a bunch of other cases. So these other cases aren't actually here. Case WM input, mouse move, button down, mouse hover, all of that kind of stuff. And then we also need to add collectors for key down, key up, and sys key up. So I'm just going to go ahead and copy these out of here. If I was doing this off of the wiki page, this code is also available on the wiki page for this. It's like a setup tutorial on the DirectX Toolkit wiki. Here, I'll show you. We were talking about this last time. I think I did show this. Oh, wait, no, we want DirectX Toolkit, not DirectX 11. Oh my God, my caps lock. Go away. There's a wiki here, right? That's got a getting started section, which has got some samples. And when you get started, there's a sample in here about, where is it? There we go. Game. Nope. Not that one. Not that one. This one. All right.
Here we go.
So what I've done is I've just done what's in here. Looks like there was something else that we needed to add into, right. We also have to, yeah, there's still some more things. So we've done the main CPP. We added the switch statement in here. So the sys key down, we put that thing in there. Sys key up in the process messages. Yep, we're all good on that side. So I think this was our original. We can go ahead and close that one down. So we're now in our new flood control. We've got game H and game CPP here. Thanks. Oh, jeez. I swear. Sometimes the useful nature of Windows gets in the way of it being useful.
Oh my gosh.
Let's go back to the wiki. Let's see what we got to do. In the game H, we need to add a couple of pointers, unique managed pointers to the header. Let's put those in right there, which means that we're also going to need to include the keyboard and mouse headers here. Right. So now we've got objects that we can instantiate for the keyboard and mouse. And then in the initialize of game CPP, we actually need to make these objects. Should be right about here. Although I think we should probably do it before the create device and resources. Where does he say to put it? It says to add it to the end of initialize. I don't suppose that. Oh yeah, it does actually, because the mouse needs to know the size of the window, and we don't know the size of the window until create device has been executed. Oh. So this command would fail if it was before this one.
Dang, you wouldn't know that if you were just following that. I mean, I guess you would follow add it to the end.
You would follow it and it says add it to the end, yeah. But you know what? There's a reason why I know that doesn't work.
Trial and error.
I tried it and then spent an hour trying to figure out why it didn't work. You know, that's what it takes to be a programmer. You got to fail a whole lot.
Good thing we love failing.
Figure out what doesn't work, really.
Mm-hmm.
All right. Yeah, this is good. So what this does is this basically just adds a get state to the keyboard every update cycle that we do. And if the keyboard escape button is pressed, then it quits the game. And so if we were to run flood control right now, we should get a blue screen that has exactly the same functionality where we started last week. And so this should basically run with a green screen, or the cornflower blue screen, and should respond to me pressing escape and quitting the application. There we go. All right. So now that we've got the setup out of the way, that's just the initial setup for getting the keyboard and mouse input going. This is kind of basically the same place where we started on what's it called, Square Chase last time. Right. I have left all of the code uncommented, unlike what I did last week, where I kind of like commented, put everything into different sections so that it would kind of avoid distracting from what's going on here, because there's a lot of code here and none of it you have to pay any attention to at all. It all does what it's supposed to do, and you can just trust that it does, and you don't need to worry about it.
Yeah,
there are
so
places where you're going to need to add some code to things, but generally speaking, there's not a whole lot of need to know what's in all of that code. I usually tend to go through and just kind of minimize all of these things. Even sometimes for some of these things, I'll actually go in and just put like a pragma region around that just to hide those, few lines. The rest of this stuff is stuff that I might actually need to know about. Rendering, clear and present, those I'm probably never going to touch, but I'm definitely going to, I'm going to touch the update, and I'm going to touch the render calls, right? Tick, I'm never going to touch. It does what it does. Initialize, that's probably all that we're going to need to do to initialize. We'll probably not mess with anything else in there. All right, so we're going to switch over to the book here, and we're going to look at what we're trying to do. I spent some time reading through what he's doing here, and he's doing some things in a certain way because they're easier in C#. And so we're going to have to recreate some of the things that C# does in our program here. For example, C# has a string.split function, and we can do the same thing in C++, but it's done a little differently. There's not like a string.split function. Actually, there may be in the STL now, there may be a string split function. No, this is Stack Overflow. This is not what I want. What I'm looking for is, see, there's Dan M is the guy that knows all of this stuff.
Dan M's
there's
genius.
A ranges.
I don't know how he does it.
Yeah, it's this right here. So I don't know how to use this, but there is some new functionality for doing range splits that are built in here. And I think this can do what I'm doing. It's just as simple to just write a small function that does that. So I'm just going to go ahead and do that. I also have the code, but I've not personally learned how to use the ranges library in the STL. So we're going to do it the hard way, which is not using the existing library. We'll just write a little function that does what we want it to do. All right, anyway.
Sounds good.
So this is the game that we're going to be making, this little flood control here. You can see this board of these different pieces. There will be colored and uncolored pieces. The logic for this needs to check to see if pipes are connected and then change the color of the pipes that are drawn. I think the controls for the game is that you click on a piece and it either rotates left or right if you click left or right button on it. And then the objective is to get the water from the left to the right side. So some interesting logic in there. Looking through the way that he did some of this stuff, like I said, he did it with the fact that you can do string.split to quickly get a couple of different values out of a string. And so he ends up storing the values for the piece types in a string, and then he parses that string for left, right. So here we go, we're actually getting into the code pieces that he's got. So he's got this a string value left, comma, right, and then what he does is he does a string.split on the comma here, which then returns the values of each of the values that are in here, and then he does a logic determination for left, and then another logic determination for right, or if the piece type is left top. So it's kind of funky the way that he does it. I think I'm going to try and do it the same way and just leave the left, comma, right, the piece type definitions as they are. So this is the vertical piece, or this is the horizontal piece, left, right. Top, bottom is the vertical piece. left top is the inverse L, top right is the L, right bottom is the R, bottom left is the backwards R.
That's confusing.
All the rest of this stuff I think is pretty straightforward. I don't think that there's going to be a whole lot of extra stuff that we need to do. So I'm going to go ahead and get started trying to write some of this code. The question is, where do we need to put it? So this is the class declaration. So we're talking about in the game header here. We're going to be creating some extra variables and other objects and things that we're going to be following here. So I've not done this before. We're doing this like pretty much off the cuff. So we'll see how it works. He's actually making a game piece class here, so we need to do that. Okay. To keep this simple for the time being, I'm not actually going to put this in a separate file. We're just going to go ahead and just put a chunk at the top of the game here. Later on, I might move this out into a separate file, but we're just going to build everything in a single file, basically. It's simpler in a lot of ways for what we're doing. Actually, when I went through the last iteration of my engine, I ended up doing that. I basically just pushed all of the code into one file initially until I got it all kind of working, all of the different parts that I wanted. And then I started pulling each of those pieces out into their own files. It was kind of an interesting process because it was more challenging than I expected, like figuring out which pieces actually had dependencies on each other and stuff like that. Was it game piece? Oh, I need to figure out some way to have this on top. Okay, so we need an array of strings. So I'm going to go ahead and use the STL components for these kinds of things. So we're going to include array. We are going to include string. I also like to do a using string equals standard. I like to put a string alias in there like that, so that if I need to change the string from a ANSI string to a Unicode string, for example, I can just change it in one place.
Smart.
This is going to be an array of strings. There's 1, 2, 3, 4, 5, 6, 7 values in here. So we're going to do a using pieces. Let's start with calling it pieces. Is going to be a standard array of string and 7. Okay. In our class declaration, we are going to have an array of pieces that is going to be, what does he actually call it in his? Piece type. So it's going to be, and then we're going to have 7 values in here. So we can initialize this pretty much the same way as like he's doing it. So it's left, comma, right, top, comma, bottom. What was it, left top that he started with?
I think so. Let's see.
Yep.
Left top.
There are no spaces in there. I can't leave those spaces in.
Right bottom.
Top right. Right bottom. Bottom left.
And then empty.
Empty.
And then also he named it piece types, not type.
Piece types. Okay. All right, what other variables are we keeping track of here? So we've got a constant piece height, piece width.
It's like 8 ints and 2 strings.
Yeah, let's just see if we can copy this out of this PDF. As mentioned, this was a book from Pact Publishing many moons ago. Let's see, that I bought for learning C#, basically. Public. So this is actually supposed to be public. So in C#, you specifically tag each individual item as whether it's public or private. You don't do that in C++. But the other keywords do actually apply, which is handy. I went ahead and just created an alias for this array here rather than defining it as an array. I think it was also const. I don't know if you can const initialize an array like that in C++.
Guess we'll find out.
I think it should be okay, because I mean I'm giving it an initialization. So
Yeah,
I'm
and changing the values.
Telling it, yeah, that I'm not then changing the value. Change that string to the capital string like what we're using here. Okay, so that's all good. We got two properties. Okay, so we're returning piece type and suffix. String suffix. I wonder what that is. Okay, so it was a return a string piece type, get return piece type. Where's piece type? Oh, okay, that's right there. And so we're getting piece type and suffix. Okay, I see what you. So I'm going to go ahead and actually name this get piece type instead of piece type. Because C# has properties, and this isn't exactly the same thing. I feel like that's what this is. Yeah, this is using the properties type thing with a get. So what this does in C# is this creates an accessor that's read-only for these values.
Yep.
Since that concept of accessor with a get doesn't exist the same way here, I'm just going to call it get suffix. So that conforms more to a C++ style. All right, so we created a new code file called game piece. We added some using statements. Yeah, we did all of that. And then we added a bunch of variables. So in the declarations area, you add an array called piece types that gives a name to each of the different types of pieces that will be added to the game board. There are 2 straight pieces, 4 angled pieces, and an empty tile with a background image on it, but no pipe. The array is declared as static because all instances of the game piece class will share the same array. I'm not sure that yeah, I think that actually does apply in C++ as well, right? Static is initialized at the beginning of the application and is just a singleton essentially. Static member can be updated at execution time, but all members of the class will see the same changes. Oh, right, static versus const. Was this a static array? Public static string. Okay, this is not a const. This is a static. So in C++, I think that it has to be const. Yes, a member with an in-class initializer must be const. So in order for this to be static, it has to be a const in C++.
Isn't that because it's on the stack?
I don't know. And I'm not sure that that's actually going to work anyway.
Heard that.
Oh, this is a weird one. I run into this problem myself. Const pieces cannot have, right? Because I'm saying that pieces is const. I don't know how to make this work. We'll just leave it as a public variable. So that's interesting. Why he's basically saying that I don't think there's ever going to be a need to change the contents of this. I mean, it's kind of an interesting thought. I mean, basically, this seems to be demonstrating something about like the singleton nature of statics, which, from the perspective of being taught what's going on here, I think that's useful. Um, but I don't think that's actually something that's absolutely relevant because we never change the values within this. I could see the usefulness of that perhaps from a memory perspective, right? Because every time we initialize a game piece, we would be initializing an array of these piece types. So it's actually quite a bit of memory. I mean, not in the grand scheme of thing, we're not talking gigs here, but I mean, that's still, we're initializing, 32 bits for each and every letter in this array, right? Plus the pointers for each of the items in the array, probably allocating some empty space for these because they're strings, right? So, I mean, this could be allocating, like 8, 10 K of memory, maybe. I don't know.
Yeah, I don't know too.
But so from the perspective of memory usage, making this static would make some sense. What the heck did I just press? Right, but we're never actually going to change these values. So, I mean,
I found something on Stack Overflow.
so I was doing something similar to this over here in my other code where I was initializing an array. Yeah, this is not static though. I need to find my services class, private, no public. So all of these, I think the way that I wrote this, all of these use, this is all static stuff. Yeah, so, oh, that's right. I was doing it inline static. That was for a map, not necessarily an array. But it could be the thing that I'm looking for is an inline static here. I think that might be the equivalent that I'm kind of aiming for. For some reason, that seems to make a change. I will admit that there are a number of things that I do that I don't truly fully understand. It's just things that I've done because it makes the squiggly lines go away in Intellisense,
Isn't that what we all do it? Yeah, it works.
I mean, I know that I've been able to make an array work like that by using inline. did this not? Yeah, there we go. Okay, Intellisense was just taking a second to catch up. Whatever. This is literally not worth caring about for what we're trying to do here. All right, then you have declared two integer constants that specify the height and width of the playing piece, along with two variables that specify the array index of the last piece that can be placed on the board. What? Max playable piece index. Okay. 5. Empty piece index 6.
So you only have 5 pieces? Doesn't seem right.
You declare two into the specified height and width. Two variables that specify the array index of the last piece that can be placed on the board. Yeah, I don't know. Next are 4 integers that describe the layout of the texture file you're using. Texture offset 1, 1, texture padding X, Y. Okay. That's going to be some stuff that we're probably going to have to figure out how to use the right values in there. There are only two pieces of information that each instance of game piece will track about itself: the type of piece and any suffix associated with the piece. The instance members piece type and piece suffix store these values. So that's why we got those two accessors. Basically what they're saying is that all of this stuff that we're keeping track of, the only stuff that's really important are these two, which is why we have accessors for them. This is also something that I use myself when I'm writing my classes. I put any variables, anything that I need to keep track of as internal. If I need to access those variables, if something else needs to access them, you make an accessor for it. Your classes should always look something like this, basically. I actually am not particularly happy about having all of these valuable values in the public space here. I would put them in private if I was doing my own thing, but I'm following what he's doing for now. It's chances are that he reads this piece type array repeatedly as part of the logic. We'll see. In order to prevent code outside the class from directly altering the views, that blah, 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 blah. Okay, creating a game piece. The only information we need to create an instance of game piece is the piece type and potentially the suffix. Add two constructors. Ah, yes, that makes sense. So we have a constructor that allows us to set the piece type and the suffix, or we have a constructor that just allows us to set the piece type and sets the suffix to nothing. So constructors are always going to be in the public section here. No prefix for it because it's the constructor. And then we need two of these. And
yeah, one with type and suffix, one with just type.
Type. And we can initialize these values a little differently here. And then this one, we just have piece type. Oops, the right button. Suffix. Nothing. All right. Okay. Constructors run when you're creating the thing. Yep, we know all that. This is intended to be a slightly beyond beginner thing that we're doing. I'm not going to call it a course. It's not a course, but we're going to assume that you know what a constructor is.
We're intermediate.
When a game piece is updated, you can change the piece type or suffix or both. So it looks like we're going to need to put a couple of methods for setting piece, with either setting the piece with the piece type or setting the, I keep on saying piece type and I'm hearing in my head piece pipe.
Why piece pipe?
I don't know. It's just because it sounds like piece type. It's like it's a what do they call that when they sound the same? Okay, so set piece, add suffix, and remove suffix. So we actually got 4 things that we're doing here. Let's just steal this code from the clipboard real quick. That'll help us halfway. All right, so we know that this is just going to be void. We don't have to have the public part in here. And I bet you this will actually pretty much all of this code will probably work. Yep, the only thing we got to change is this string because we're using all the same values here. So this is a great example of exactly how similar C# and C++ actually are, right? Is the fact that this code with very minor, well, we got this contains function here this looks like something contains. Oh, we're going to have to figure out what he's actually doing here. This one, what we're going to do for this right now is that we're just going to comment that out because it's not going to work until I figure out what it is that he's doing. It looks like, again, he's using some kind of a string library here. So I think the suffix, I think the way that the logic works for this, I'm vaguely remembering this. The suffix is basically a comma separated string of values. Yeah, so he's leveraging the C# string library there. We're going to have to figure out what contains and what replace does and recreate those in C# or C++ or use something from the STL if we want to put some time into figuring that out. All right, the first two methods are overloads with the same name, different parameter list. That's a useful thing to know about. Overload. You can have
overlords.
evil overlords. You can have a function that has the same name, right? As long as the signatures are different. And so in this case, the funny thing about what he's doing here is that if you call the set piece with just the type, it'll then call set piece, passing along the type that you gave it and 0, versus if you call set piece with type and the suffix, it'll set those both there. It's a neat little piece of recursion there. Helps you kind of save yourself from having to write multiple code. Because look, if I was to do it like this, piece type equals type, and then piece suffix equals quote quote. Now, if I made some change to this code, I'd have to remember to update this function and this function. If we just pass this along with the parameters preset like that, and I need to make some change to this, then I only get to change it here. It's a good practice. I think that was the one thing that I really liked about this book, was that the guy was very, very good on best practices and like recommended ways to write code and design your classes. And I really liked the way that he steps through it, because it's all very logical, piece by piece, building on the concept. So I think it's going to be valuable in the long run. Additional methods have to be added to modified suffixes without changing the piece type associated with the piece. The add suffix method first checks to see if the piece already contains the suffix. If it does, nothing happens. If it does not, the suffix value passed to the method is added to the piece suffix member variable. I think I skipped over the description of what suffix do earlier on in this, probably. Yeah, so he's using the replace method of the string class to remove the past suffix from piece suffix variable. So if I was trying to do this in C++ a little bit better than how he's doing this right now, or maybe not better, but maybe a different way. And this was one of the things that I was thinking of early on too, is that what I might want to do here is, rather than having these items in this messy, oh, where did it go? In this messy array of I lose my code all the time. What is wrong with me? Like, so I wrote this code somewhere, didn't I?
I hope so. There it is. No.
Oh my god, that's hilarious. Like, where did I set up the array? It's in the game header, isn't it?
It was in the game header. It was where? Wow. Because you made a public and a private. Did it go?
No.
Here it is. No, it's not there.
I wrote.
Yeah, here it is. Right?
No, I mean, I like typed up the entire array in the code.
You mean the left top, bottom, right?
What the heck? Okay. It was when I was doing this, right?
Yeah.
That's when we created the why. Where is my pieces?
It's go to piece type. I think you have it.
Oh yeah, it's right there. I collapsed it. That's why I couldn't find it. Jeez.
Oh man.
Yeah. So what I was thinking about doing was basically creating an enumeration that has the values left, right, top, bottom. That would be all of the names, and then basically instead of well, I couldn't really figure out a good way to do the piece type check doing it this way, but instead of basically instead of having this be a string, I would have it be an object of 2 of the enumerations and a vector of suffixes, right? That would all be of the same type. So these would actually end up really being just numbers, 1, 2, 3, 4. And then, you know, in the back end, the logic would then, I would just search for the values left, right, top, bottom, let's continue doing this with the string. It does make it a little bit more challenging though, because in order to do the add suffix, so contains, I think what we should do is we should actually look at what string.contains does in .NET. So if you're searching for a string indicating whether a specified substring occurs within this string, so that's all it's doing, is it's just looking to see if any part of the array or of the string matches the string that's provided. Let's see if there is something similar to that in the STL. I think this might be a good time to learn how to use range. So there's substring, right? Length, replace, insert, erase. I wonder if they're actually string.find. This might be the thing that I'm looking for. Search the string for the first occurrence of the sequence is specified by its argument. Okay. So the string find method will do what we want to do here. So that would be actually, I think this code is fine if piece suffix dot find should be the only thing that we need to change. Find suffix, yep. All right. That would do the same thing. It would add this string to the piece suffix value. So he's not comma separating it. This value might actually be kind of dirty looking when you actually look at it in the debugger, because it may actually end up being just like a literally just a left, right, top, bottom may be written into this string, you know, with no commas or separations or anything like that at any time. This I'm not sure that we can do with the STL. Is there a replace? I know that there's a substring. Oh, there is a replace. Look at that. Isn't that amazing? That the standard template library has all of these wonderful functions already built into them. So it's almost as good as C#.
It's incredible.
It's
We're good.
It does look
Thank the
like it's
programmers.
pretty much the same thing. Piece.replace, two values. Oh yeah, right. Because this you can tell it where to replace. So string.replace, you have to give it the indexes that you want it to replace from and to. Let's look at how this thing says. So this is a test string. String 2 is an example, sample phrase, useful. So we're saying standard string str equals base. So this starts out with, this is a test string. Replace 9 to 5 with string 2. So that would go from 1, 2, 3, 4, 5, 6, 7. Oh, okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we append. Oh, he's replacing everything from there. I don't know what that second value is. What's the second value? Oh, it's how many characters to replace. Yeah. This doesn't work exactly the same as the C# one because the C# one actually finds the value. So what we need to do, so what does find return? Does find just return whether it's found or not, or does it return a position? We should look at the 14 version of it. I'm looking at the wrong thing now. I'm looking at string dot. I need to look at find again. String dot find.
Looks like it just returns an iterator to the first element.
Yeah, I think that's what it should do. I'm just when pause it only includes characters at or after. Return value, the position of the first character of the first match. Okay. So we need to do a so we got to do a piece suffix find first in order to this returns the beginning. I also need to know the length of the suffix, right? I think we also need to do that check to see if we can actually find it, because if I don't know what begin would return if it didn't find the suffix, right? Like what would begin return if it didn't find a match? The function returns npos.
What is npos? Just like no
position. Yeah. So it's if begin equals npos, then return or something like that. Okay. That should do it. Actually, you know what? What I'm going to do is I'm going to actually tell this to throw. I'm just going to put a generic throw in there that'll basically just break the app if this is not found. I'm going to trust that there's a good chance the logic that he's writing is written in such a way that it will never match that condition where you're trying to remove a suffix that doesn't exist, but I don't have any way to know that right now. So then to actually do this replace, we now have the beginning and the length. So then it's replace from begin to length suffix. Wait, no, we're replacing it with quote, quote. That's the erase it, right? Okay. So that should do that. Assuming that assuming that that's what we're trying to do here, assuming that that begin thing works the way that it's supposed to, or that I think it does.
Cross our fingers.
That's looking good so far. Okay, so we basically just recreated the C# commands for that kind of stuff in C++. A little bit more complicated, but generally the STL seems to provide most of the same kinds of functionality. I mean, that's the purpose of the STL. It provides common functions that programmers always need, like searching strings, for example. All right. I don't know about any of the rest of this. Creating a game piece. Yep, we did that. Updating a game piece. Yep, we did that. So now we've got rotating pieces. All right. The remove suffix message uses rotating pieces. At the heart of flood control play mechanic is the ability of the player to rotate pieces on the game board to form continuous pipes. In order to accomplish this, we can build a table that, giving an existing piece type and a rotation direction, supplies the name of the piece type after rotation. We can then implement this code as a switch statement. This, I remember, was the reason why I got stuck on this, because in C++, you can't switch on a string.
No.
Yes. So I was thinking through this, and I was thinking, how would I deal with that? Because I think there was a way to do that. I think I just had to do, yeah, I think we just have to do it not with a switch statement, because a switch can't really switch on strings in C++. Whereas they can in C#, which is fancy, but it's something that C# does. All right, so rotate piece clockwise or not as a Boolean. So that's whether you're clicking left or right on it. So we've got to recreate this, but we've got to do this in C++ because I don't think this function's not going to work as it is here in C#. This is also on the game piece, right? We're still in the same. Yeah. All right.
Game
so
piece.
yeah, so this is where it's going to complain, right? Because this has to be in an integer or an enum in C++. So a couple of thoughts that I had was, like I was saying earlier, we could, change these piece types to be like a collection of enumerated values, or we could create an enum for piece type left right, piece type left bottom, all of those different kinds of things. But
Yeah,
the reason why he
thinking.
was doing it with strings is because there's other logic that also uses this. So I think instead what we're going to have to do here is we're just going to have to say if piece type equals left comma right.
Yeah, that might be the only way.
Right. And then, oh yeah, right. Oh, right. But then we need to make sure that we return after those two, right? Because I was about to write if piece type equals top bottom.
Oh, then that would make any sense.
Would have been set from the previous one, right? Piece type equals then piece equals left right and return. And he's breaking, which is effectively the same thing. You break and then you leave the scope of that function. So putting a return in there is fine. Okay, so if, well, no, let's use let's use what code is here so that I can write less. So just say if top. And then we have in here 2 blocks of logic. If we're clockwise, then we turn our piece type into a top right. If we're, nope, I like that being small. So I'm going to change that. That's just me. The important things about writing code. See if it's this, if it's that, otherwise return. Okay. Got to get the important things right.
The important small things that really matter.
It really does in some ways. Oh, so much typing.
Yeah.
Whew.
There you go.
I'm pretty good, I think. I mean, I think I've got a pretty decent typing speed, although my error rate is pretty bad. But still, a lot of typing. All right, and the last one. So, I mean, ultimately, a switch statement is really, it is nothing more than a fancy chain of if statements, really. I mean, I think maybe the one technicality is that in a switch statement, it's well, no, actually, a switch statement does a few things differently than if statements can do, because a switch statement allows you to fall through in multiple cases, which is not something that you can really do with an explicit if statement. For what we're doing right here, this is fine. We can do it with just these simple if statements to replace the switch. But if the switch was doing anything much more complicated than this, it would be more code to do this. But this does appear to work as far as C++ is concerned there. We'll have to test all of these things to make sure they actually do what they purport, but I'm pretty confident at this point.
I believe in you.
All right, what just happened? The only information need rotation direction, right? Whether it's clockwise or not. Left right piece will always rotate top bottom and vice versa. Pipe connectors. Our game piece class will need to be able to provide. So we're going to add some more methods, and these are going to be for allowing other objects to query about the connection ends, the connection possibilities of this piece. Okay. Get other ends. Well, that's interesting.
Sucks that this thing uses so many strings.
Yeah, well, that's what I was saying. Like, he's only doing this with strings because the string library in C# is really handy. And so he's doing a lot of this stuff just because it's easier at this point in the course or the book. I mean, later on, what he's actually doing is later on in the book, the way that we do these things is much more advanced. He's just using strings because they're easy in C# for these kinds of things, which does make it a little more challenging here, because then I have to figure out, how to replicate that functionality in C# essentially.
Yeah, makes sense though, but yeah, struggle for us.
This was find, right? We knew that this was the same function. So, what's really actually kind of funny about this is that when you look at some of this, when you think about, the people that are writing .NET and stuff like that, there's a piece.contains function, and the chances are the .NET compiler just converts that into a .find call in C, against the STL. I mean, Microsoft uses the STL internally for all of these kinds of things as well. So, I mean, there's no reason why the .NET.contains function doesn't literally just pass that on, through the compiler into a C or C++, STL find function. Why would the C# developers, come up with their own way to do that, right? And the functionality already exists in the STL. I gotta blow my nose again.
Yes.
Now, I know that the other thing that we're going to have a little bit of a problem here is that this is returning an array of strings.
Boo. Make an array of chars.
Well, yeah, so what we'll do instead is we'll return an array, a vector of string. So he does to array in order to do this at the end. But the list object in C#, the list is most similar to a standard vector.
Don't you have to change the string in front of start and end the string capital?
What? Oh no, I'm trying to decide whether this is the right. I think this ends right here. We don't have to do a new string, and that's a C# thing. Yeah, this is going to work fine in C++. What I'm doing is I'm instantiating a new vector on the stack right here, and then I'm going to fill that vector, and then I'm going to return that vector, which will do a standard move. So it doesn't reallocate it anyway. Ooh, wow. that's a dense that's a dense statement right there. For each string end in piece type, string there's no, so the split function returns an array is what's going on here of values. It basically returns quote top and quote bottom as an array. So what we really need to do here is we've got to we need to write a little function to do the split for us, I think. Oh, wait, no, we need a string. All right, I had written some code to do a string split in.
The question is, where is it?
Yeah.
Find
it. Yeah, where? The question in my mind is actually, what was I using that string split function that I wrote for? That would lead me to where that code might be.
Can't you just do Control F and find it?
I was thinking that. Was thinking maybe can I just do a find in this entire project here? Entire solution. I had a moment. I had a moment. I had a moment thinking that I might have remembered where I put that code.
I gotcha.
I've got some generic services. There we go. I bet you it might be here. I've got some generic. No. We'll just figure it out and do it again. That's no problem. So it's the substring function, right, that we're looking for. So we got to find the index of the substring to find where the, yeah, so we got to find where the comma is. So this is easy. We do input dot find delim, right? So this is index.
Wait, what is delim?
Delim is the delimiter that we're going to pass
Okay.
the parameters. So like this right here is the delimiter.
Oh, yeah.
Delimiter. This is actually a char, not a string. So I'm assuming find can take a char as well. Yep. Okay. So this tells us where the comma is. And so now we need to do an input. Let's see, auto. No. Let's see. Vector of string result. result dot imply no pushback. And then we need to do input dot substring from 0 to delim. That'll give us the, I don't know if that'll include the comma or not. If that gives me the index of where that is, let's look at that documentation again. Substring character to include. Oh, it was find, not substring. Yeah, find position of the first character to be this is greater than string. I'm using find, right? Yes. Return value, the position of the first character. Let's just look at the example, see if we can figure out what it's actually doing. Needle. First needle found at the value that it's found. And do we get to, it's found at 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 0, 13. It's going to return the number 14. So I think that puts us right before the delimiter. The delimiter. What the hell? Why can I not say that? Delimiter. Delimiter. Yeah.
Eliminator.
That puts us just before it. So for the other part, we want to result pushback input dot substring delim +1 because we don't want the comma. And then we just need the length. We just need to the end, right?
Yeah.
So that should then return result. That should return a vector of 2 strings, right? And so then what we're doing here is we're doing split. Whoa, hold on a second. I need to figure out what he's actually doing with these values once we're in here. Oops. If n yeah, we can't do it this way here because wait, no, that should work, right? Oh, but we need this. We're splitting piece type. So split piece type.
Seems to work.
Yeah. What is opposites? Opposites of vector. So opposites dot back. And then we just return opposites because it's already a vector. Yeah, that should do it. I mean, there's a number of ways to do that. This works. I'm good with following the way that he's doing this here. So you can use the STL algorithms for each to do this. You could write this for statement using your standard, index, auto I equals 0, I length of, there's a few different ways to do this. C++ does support several different for statement formats for the parameters that you provide to it. So this works, I think. We wrote our little split function, which should return 2 strings if end does not equal starting end. Oh, right. That makes sense. So if we know what the starting end is, right? I think that's good enough for now. I mean, I don't fully know, fully remember exactly what all of this stuff is used for either. So we may have to do some some debugging at the end. This was fine. That worked the way that it was. Okay. The get other ends method creates an empty list object for holding the ends we want to return to the calling code. Then uses split method of the string class to get each end listed in the piece type. For example, top bottom will repiece. Piece will return an array with two elements, top and bottom, right? First element will contain top and the second will contain bottom. Comma delimiter. That's I was calling it delimiter. It's delimiter.
I was thinking Terminator now.
Yeah, it's the delimiter. Will not be returned with either string. If the end in question is not the same as the starting end parameter that was passed, it's added to the list. After all of the items in the string have been examined, the list is converted to an array and returned to the calling code. Not true in this case, as we're just using STL vectors, which kind of simplifies all of that. Not necessarily the most performant way of doing it, but again, we're doing a lot of things here just for the sake of getting it done, not because it's the best way to do it. The concepts I think that we're trying to teach here are about like how to design classes and how to work through this logic, right? So if you think about, and this is kind of the same way that I think through, when I'm building stuff in my own application, is I kind of think about, what does this thing do? What is it supposed to be doing? What information does it need to provide to other pieces of the program, right? And so I think this, very very easily kind of distills that down, that concept down is like, let's think about what do we need, and then let's write some methods to do it. Think about what we need, write some methods. That's kind of the way that I go through when I'm writing my own code as well, just iteratively. What do I need? What do other people need? How do I map the connections kind of in my head between these different pieces to figure out what functions to write, really. Simply returns 2 if the piece type string contains the string value passed in. So it has connector. Yes. Now, hold on a second. I'm doing a piece type return. This is not actually going to return a Boolean, so this won't work. So what I actually need to return is the true or false statement. So in order to get a true or false statement, I need there we go. We need a comparison there. So if no, not equals end of position. So the return value that we get if we don't find the value is npos. So we check to see if we can find the value. And if we do find it, then we'll get a number. The answer will not be npos. And so we will return true. All right. So a little bit of a change there, because the find function in C++ does not return a Boolean, it returns an integer. All right, game piece class methods, get source rectangle. Oh,
To get the sprites.
no. I know this one, but here's something that's actually kind of funny about this. So this function will work as written. I need to add one header from the DirectX toolkit. Simple math. Simple math gives me all of those things like rectangle and vector2 and all of that kind of stuff. So rectangle will work. As long as I have the fit. Did I just forget how C++ works with using namespace? Oh, you don't specify namespace, do you?
You have one up there in the top right says using namespace DirectX.
Right.
Maybe you don't need namespace for this one. I have no idea.
No, maybe there's no simple math. I swear to you, Microsoft has been screwing up Visual Studio's editor so badly for the last like 2 or 3 months. It's getting ridiculous. Like, I know what's going on. They stripped the Visual Studio editor out of it. It was, you know, a custom built .NET component that worked fantastically, and they've been replacing it with a VS Code editor that's crap. So a lot of stuff like this just doesn't work for no apparent reason. It's just because like Intellisense is actually popping something up, no members available, down at the bottom here, because it's not done processing what's going on in this page. It probably has not realized that I added simple math. It's extremely frustrating. Like,
that's so annoying.
Rename symbols has been not working correctly a lot of the times, which makes refactoring really, if you like, if I was to change this to, you know, from tick to like tick 2 or something like that, and then went and tried to rename update to update 2, and then try to get, by the time I got to render, I can almost guarantee you that the editor would not work anymore. That the renaming function would pop up with, I can't figure out what's going on. It's just, it's absolutely ridiculous. It's been pissing me off. I've literally sent like 17 feedbacks in Visual Studio over the last 2 months on this stuff. Every single one of them gets triaged as a bug too. About half of them are already reported by other people as well, which makes me feel a little better. There is no reason why this shouldn't work right now. Oh yes, that's not going to work because I'm trying to put it inside a class. So yes, it is my fault. It's not.
Wow. Oh my goodness.
Hey, that was a good rant though. I mean,
It was.
what I said was true, because it's really been annoying. All right, we can put that using statement up there, and now the rectangle should work. Public doesn't need to be here. So a rectangle structure is 4 longs that are X, Y, width, and height. That is actually not exactly the same as the system rect structure. This was something that took me a little while to figure out. It was throwing some bugs into a lot of the stuff that I was doing. I don't know if you've seen I'm just going to run my little test application here for the Clay Engine stuff. But like some of the stuff that I was doing in here, like figuring out exactly how to size these different pieces, just some of the stuff that I was doing in there was absolutely hilarious, because the rectangle object has a way to return a rect. So here, let me show you this. When you go into the rectangle structure here, you'll see that there is actually an operator rect right here. So what this means is that if you assign a rectangle object into a rect value, it'll use that operator and convert the numbers as they need. So if you look at it, this is what you'll see, is that the rect value actually uses different numbers or different values than the rectangle. So the rectangle uses X, Y, width, and height. The rect structure uses top, bottom, left, and right as absolute values. But
wow,
it uses this operator so that you can do something like this, where here, let me just, I'll write some code in here that'll just show you. You can do like rect x equals rectangle, 1, 1, 10, 10. What you'll actually get there is that the x value will have a top, bottom, left, and right. And that right value, for example, would actually be 11. Because what it does is it takes this XY location. Well, actually, I guess it would still be 10, wouldn't it? But starting at, well, no, yeah, it would be at 11, right? Because it'll start at 1, 1 and go 10 over, which would end up at 11. Right. So anyway, the point is that I didn't realize that there was a difference between rect and rectangle, because that was transparent in the simple math library. And so I ended up coding a lot of bugs early on, because I was thinking that the rect and the rectangle were literally the same. And so I was using like left, right, top, bottom values when I should have been using X, Y, width, height, and vice versa. Using
Gotcha.
width, height when I should have been using top, bottom type stuff. So anyway, what he's doing here is he's manipulating just the X and Y values of the rectangle, which is fine. There is one minor difference, though, is that the rectangle uses long instead of int, which I don't think long, well, maybe long is a type in C#. I don't know. Do you know?
Like long or just long?
No, long. It's so long is the 32-bit int, and long is the 64-bit int. I don't know. I don't really know C# all that well. I don't remember if long is a type in C# or not.
Oh, long.
I know short is, so it probably is.
Yeah, it's in
I think
C#.
it's probably the same int. This is texture offset X and Y. That's the one here. So yeah. We're just going to change all of these to longs because that's what we're going to be using in the rect structure. So this probably also needs to be changed to a long too. Leave the rest of them alone for now. I just happen to know that the system uses longs for all of that. So it is, probably worth noting, you've said it a couple of times, is that like, you do have to just kind of know some of these things.
Yeah, just gotta know it's gonna work and then implement it.
Holy crap, what is he doing here? So we don't have to say new rectangle here, but
I guess he's getting the index of pieces type.
yeah, I'm trying to, so this
piece.
is a plus equals that he's doing to the Y value here.
God.
He's multiplying this by that. So what is he really trying to get here? Index of piece types. So he's trying to find, okay, I see what he's doing. Cool. This has to do with the multiplications that you have to do in order to find the graphic in the artwork. So when we look at our tile sheet, there we go. The tiles are laid out in this order: left, right, top, bottom, left, top, top, right, right, bottom, bottom, left, and empty. So what he's doing here is he's looking for the piece type that it is, and he's using that to find which value in the array is that. So let's say we were doing something like this. So let's see, we would want to do 4. No. We want to do, because we want to use this value. So here we're going to do another variation on our for statements here. This is just going to be I is less than type dot size. Yeah. And then what we're going to do is we're going to then let's do it like this. just because I'm being kind of lazy and I'm not writing the most optimal code. But what is what we're going to do? We're going to iterate through this thing. I'm going to say if piece type I, because it's a vector, so a vector has a bracket operator on it, equals term. So this the piece type should return strings, right? And this term is a string. I don't know why it's complaining about the equals equals there. This is this thing making not nonsense. This is the length of the piece type array. If the piece type at this index equals the term, this, oh, piece type. We want piece types for the array that we're searching. Yeah, there we go. If piece types equals the term, then IDX equals I. Return I. Find piece type. Yeah, so what I can actually do here is that if I find this, I can just return I right there and then just be done with it. If it gets to here, we're going to throw, because we shouldn't have gotten to there. We should have found something, right?
Yeah.
That means that I don't need this. Yeah, there we go. Okay. So now I'm calling find piece type. That should return my multiple on whichever index value it is in the array. That should give me my right number for my source rectangle. So depending on whichever piece type it is, I should get a rectangle that represents one of the locations in that, where did it go? It should represent one of these locations in one of these tiles here. All right, back to the book. I think we're done with that one. Rolling right along. Oh man, we're almost at the 2-hour point and we haven't actually gotten anything that we can draw on the screen yet. We're going to have to pick this up next week.
Yeah.
Well, you know what? Actually, we started a little late too, so I guess we probably can go till about 6:15.
Yeah, that works.
The 2-hour mark. List in the game, please cut, blah, 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 blah. He's telling us about all of the stuff that we did. And this is an explanation of like the values that we just calculated in there. So the next thing to do is to move on to the game board class. So it looks like the game piece is complete at that point. That might actually be a good stopping point.
Yeah, you
maybe we'll
test
put
it,
together.
wanna...
Yeah, let's put together. Well, I mean, the only testing that we can do at this point is that we can test to make sure that it compiles.
Yeah.
Which I'm pretty confident will be good there. Ooh. That was a good fix, or that was a good find. This is not the delimiter, it's the index of the delimiter that we want there. Okay.
Perfect.
I think that was the only bug that we had, though. It looked like the only problem. Looked like the only problem.
Wow,
yep.
Look at that. Beautiful.
So, yeah, I think the next thing that we got to do is class game board. And we'll be doing the same kind of thing for this one. I'm trying to decide if I actually want to keep going or not. think we could leave it at this point. You know, we got everything kind of built and compiled for the game piece the way that it's supposed to. I'm not going to be able to test whether the code changes that we put in there to kind of convert it from C# to C++ type stuff. I'm not going to be able to test whether that'll work until we actually have a class that uses it. But the fact that it compiles is a good sign. I think that's a pretty good indicator. I'm going to change a couple of things here. So these functions that we wrote to replicate some of that .NET stuff, I'm going to move them into the private section of this class. Because they really wouldn't be useful for anyone outside of this class. In particular, the fact that I'm directly referencing these internal values right here, this function can only be an internal function. There's no value that well, I mean, I guess you could pass the find, you know, you could call find from some other thing and just pass some random term, but it's just going to result in a throw most likely than not, right? So this is an internal function. I like to kind of name my internal functions differently from my public ones as well. There's a couple of different thoughts of how to do that. I think I just will change them to lowercase to be some kind of indication on my side that I'm calling an internal function. Other than that, I don't think there's really anything else that we can do to this class until we get the other piece of it in place that needs to use it. So the game board is going to contain like an array of, you know, 100 of these or whatever. And that will all be at some point that I think we'll probably have a game board instantiated here. Plenty more to do. I think this is a good stopping point. We'll pick up the game board next week when we continue.
Sounds good.
And yeah, and so it's put the, oh man, that's can we do this in 20 minutes?
No, he's gonna be rushing it. It won't be good for them.
No, let's not do this. Yeah, let's wait till next week because it looks like looks like the game board and the update are kind of both relatively short sections here. So the game board doesn't look like it has a whole lot of code to it, and then really all the rest of it is just the update method for, you know, for the game pieces and stuff. So we're gonna keep this right here. At the game board class will be the next thing that we'll do next week. Again, just kind of putting all this stuff in the same file just to keep it simple. I promised on the first one that I would put up a Git repo for all of this code, and I still have not done that because, as you can see, this is all still integrated into my main project that you know I've been working on for 5 some odd years. So it's I'll try to get this stuff extracted. At the very least, I'll try to get the Square Chase project extracted and stuck up on a GitHub so that you guys can download that one and see if you can fiddle around with it and maybe you know, modify the Square Chase so that it like keeps track of how many times you actually click consecutively without it you know, without missing or something like that. It would be a fun challenge. In fact, we have 15 minutes. We could do that. What do you think? That should be a totally easy mod at the end of this, right?
Sure.
Let's do that real quick. So the only thing that we're doing here is that we've got this player score, right? And so in our update cycle, we want to, if, let's see, so this is left button contains, right? So what we're going to do here is we're going to add another variable to keep track of if we have consecutively clicked. Right, so time remaining, and then we get the state, and then we check to see whether we contains that. If we contain it, then we increment the player score, and we set our time remaining to 0. Otherwise, we decrement our time remaining. So we want to say that we have consecutive, let's call them consecutive clicks equals true. All right, so that means we need to add a header for that, or a declaration for it, of course. set it to 0 to start with. Oh no, this is a Boolean. False, yes. Int. So if we get into here, we say our consecutive clicks is true. If consecutive clicks is true, then we have to know whether we were correct the last time, right?
Yeah.
Oh no. We just consecutive clicks count. To clicks count. Consecutive clicks count plus plus, else consecutive clicks is false. No. Consecutive clicks count is 0. Right? So if we manage to get in here where we've clicked and we've actually hit it, right, then we set clicks to true and we start incrementing the consecutive clicks count. And if we're not true, then it'll force this branch to go into this else, which will set counts to 0 again. Okay, and so then we only need to add, oops, a little bit more to the end of this. We do and consecutive clicks count. All right, let's see if it works. How's that for a challenge? That wasn't even a challenge. It was the wrong project.
I didn't take 15 minutes.
Yeah, I said we have 15 minutes. So that's more than enough time, was what I was meaning. All right, let's see if it does it. Consecutive 0, 1. Oh, no, it's it does not seem to have right. So what we need to do is we need some additional logic in there. So if it contains, we set consecutive clicks to true. If consecutive clicks increment this, if we need to set consecutive clicks to false again. So we need to only go through there if our consecutive clicks is set to true. That's kind of, I don't know, that's like setting that flag to true and false like every single frame. I'm like toggling it back and forth. I feel like there could be a better way to do that, but I'm pretty sure this will work. I wanted you to actually run it, not just compile it. Thank you. Oh, no, it's but we only wanted to set it. Oh, so it's what it's doing now is it's almost instantly setting it back to 0, right? Because I'm setting this to false right here. That's what we need to do, right?
I think so. Let's see.
No, because this is just gonna leave this incrementing. We need it to set consecutive clicks to false only if you've failed to click after the timer, or if you've only failed to click before the timer is expired. So what we need is if time remaining is less than or equal to 0. Wait, is that how it works, right? Then consecutive clicks equals false. Meaning if we've gone past the expiring time, then set our clicks back to false. I think that's how the expiring time works, right? because we're subtracting it from this time remaining. Okay. All right. Last one. See if it works this time. All right. Boom, 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 boom. Nope, still doing it. It's setting it back to 0 immediately. Oh, come on. You got to know how to fix this, Kevin. Come on, help me out here.
I'm still thinking it through.
We need a way to track the last click, right?
Yeah.
So if we have hit, so we're in our update cycle. If we've hit inside of it, we're true. We may go through this update cycle, and the only time this changes is, the only time this goes is when you actually click inside the box. It sets the time remaining to 0. That's why this then executes and switches it to false. If consecutive clicks, it increments this. Oh, right, because the second time that it goes through here, it doesn't hit this contains. So no, that just means that it doesn't go through. Right, it doesn't go through here, but the consecutive clicks value is still true at this point. So it should still hit here, which is why it's increment. Wow. Okay. So that is actually a lot more challenging than it seems.
Yeah.
So let's leave that as a challenge for anybody else who wants to try. I'll remove my attempted botched implementation here from this one before I upload this to the GitHub. I think that does actually end up working out to be a pretty decent challenge for this one, is modify this to keep track of consecutive clicks, because I didn't really think that through, but you know, you've got that update cycle running over and over and over again. There's got to be something else that we got to keep track of somewhere else.
At least they know what not to do now.
Yeah, at least we know how not to do it. Doing it that way didn't work. Right on. Well, all right, cool. So there's a challenge from the first week there. We can try and modify that old project. Like I said, I'll try and get that uploaded, set up a GitHub site for that and get that uploaded sometime this week, whenever. I mean, it's going to be a few weeks before this episode gets released anyway, so I'll try and make sure that you can put the link to it in the post when we publish.
Sounds good to me. Yeah, just once you send that to me, I'll post it.
Sounds good. All right. Well, thanks for joining me again. That was pretty fun. I think we got quite a bit done there. I hope that this was educational and useful for people, kind of seeing some of the differences between the languages of C# and C++, and some techniques there for like looking things up and figuring out how stuff works. A lot of what I was doing there was just kind of off the spot riffing. It's like, okay, so what is this trying to do in C#, right? And then just trying to figure out how to replicate that. Ends up being a little more complicated in C++ sometimes, but we also discovered that sometimes there's already STL stuff that'll do that. I think, again, referencing our good friend Dan M, I think that there are probably some ranges library stuff that could do some of that code that I wrote in there by hand already. I'm just not familiar with the library, so fun stuff. Ready for next week?
I'm ready for next week.
All righty. Well, I think that's the end of it for today.
See you guys.
Well, that's it. Thanks for listening. You can find all courses at GameDev.tv or in the show notes at a discounted price. Get started with your game development journey today.